Hi, sixth graders. Today we are going to be creating histograms. A couple of disclaimers first. My children are still awake for this filming, so I might be a little distracted by them, but we hope to not see them in the background. Also, two things that I want to make sure you know before we get started is that today is very similar to the day where we created Box and Whiskers together. We are going to be creating two histograms together. So today's a day where if you want to pause it, because I'm going a little too fast because I already know the numbers, please pause at any time so that you can get caught up. Also, this picture has been saved to today's assignment on the Google Classroom or on your assignment page. This is the entire data sheet. I don't expect you to copy it down, but you might have a couple of options. Maybe you have a printer at home and you want to pre-print it beforehand, or maybe you just click on the picture and have it open so you can keep referring back to it. I know I've also talked to some students where they have two computers in their house. So this might be something where you have this picture open on one computer and then maybe the assignments on a different computer or whatever you want to do, but you want to make sure you have this handy. Also, you will see that the two different histograms are also shown on the Google Classroom. I would take time right now, pause if you want to pause, but I would take time right now to pre-make both of these just so you have the bones of the histograms already made so that you're not kind of scrambling to keep up. But here's some hints as you're making it. I made it on grid paper, so if you have grid paper at home, maybe you want to make it on grid paper yourself. But if not, we're going to be graphing the exact same data twice. So if you're a person who likes to count by certain things, maybe count how many lines that I've spaced. Also notice that I know you probably can't see it on the grid paper, but I counted out 4 spaces between each of these, and I counted out 2 spaces between each of those. So if you're somebody who's pre-planning a lot for this one, I would definitely go ahead and do that. But again, we want you to make the histograms with me today. So pause right now if you need to get caught up on this. Otherwise, I already have mine ready to go, and I'm going to start my histograms. So the frequency table that the textbook, this actually came straight from the textbook, the frequency table that the book gave us was that was students' travel times to school. So they have the students' initials, how long it takes them to travel to school, the distance that they travel to school, and the mode of travel, meaning how they got to school. This is one of those frequency tables where they gave us maybe more information than what we need to create the histogram, but if we want to kind of look at maybe why some people had longer travel times to school, maybe information about how they got to school or how far they lived, could give us that extra information. So something I want to point out, the reason the book is having us do the exact same histogram twice is because the first time they want us to have the x-axis going in increments of 10, and the second time around they want us to have the x-axis going in increments of 5. And we're going to compare and contrast both of them, okay? So to start out, I just told you the book wants us to count in increments of 10 for this particular one. Based on what we did the last lesson, and I kind of gave you some hints about how to count in increments, I want you to first think before I start to write what increments, if we're counting by tens, what that would look like. So I'm going to grab a marker here while you're thinking about that. And so the hardest part about making histograms is getting those increments. So I'm going to first show you what I don't like. So when I'm teaching my students, this is what we kind of do first as that mistake, and then we go back and fix that later. And if I'm counting in increments of 10, a lot of people just like to put a 10, 20, 30, 40, 50, 60, and 70 here. And that doesn't sound so bad. And when I was looking at pictures of histograms preparing for this lesson, I saw a lot of sources that do that. But the problem that students have when they make histograms this way is that, let's say somebody walks, like I have a couple people in our data table that do. I'm sorry, they might not walk, some of them bus their car. But if they have to travel 10 minutes to school, where are you going to put the data for 10? On this side or on this side? And that's where the challenge is for getting where they go. So instead of marking 10, 20, 30, 40 like that, you could, but what I tend to do is underneath them, so I'm finding a different color here, is I'm going to do it as an interval instead. It's called an interval. This would go from like 0 to 10, and then 10 to 20, and then 20 to 30, but we still hear that overlap, 0 to 10, 10 to 20, where do I go? So if I'm counting by tens, I'm going from 0 to, now think about that. I'm going to count by tens. 0 to 9 is actually 10 data points. The next one then would be the 10 to 19. And then you're going to have your 20 to 29. And now I want you to notice a pattern here. This first interval was all of the ones. This is all of the tens. This is all of the 20s. This will be all of the 30s. This will be all of the 40s. This will be all of the 50s. This will be all of the 60s. Okay, so it looks, deceivingly, it looks like we're counting by 9 because like 19 minus 10 is 9, but it's not 9, it's really 10. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 is really 10 pieces of data. Okay, so now that we have that filled out, we can go a little bit faster. Again, pause if you need to finish yours while you're doing this, but I'm just going to look at the frequency table and count how many pieces of data I have that are from 0 to 9. And from 0 to 9, I see 6. Oh, I forgot to label my y-axis. My apologies. I'm looking at my data table. I've already predetermined my y-axis. I'm going to count by 2s. So I have 0, 2, 4, 6, 8, 10, 12, 14, 16. You know what? I left room for one more. Let's go all the way up to 18. So my 0 to 9, like I just said, there are 6 pieces of data from 0 to 9. So there are 6 people that take somewhere between 0 and 9 minutes to be able to get to school. I made my bar 6 tall, and I'm going to quickly shade that in a color. And I'm going to keep on counting. My next gap from 10 to 19, 10 to 19 has 17 of them. There's a lot of them. So from 10 to 19, I count 17. So when I'm making this graph, just like we did in the previous book, since I counted by 2s, I'm going to have one line halfway in between. And I'm going to shade that one in. Okay. So I know that some of you might just be doing this in pencil, and if you're just doing this in pencil, you might notice where some things could get a little bit more challenging. I hope you can see that I'm alternating between green and yellow, just because when the bars are side by side, it's nice to have them alternating colors just so that you can, be able to see each bar differently. So I encourage you to pause right now and try to finish this off by yourself. And I'm not going to kind of do a whole lot of talking here for a minute. I'm just going to kind of finish my my histogram. I'm not going to have my husband stop recording because I don't want to have to piece multiple recordings together. So he's just going to keep on recording as I try to finish this off as quick as I can. Hopefully you are pausing at the same time and doing it yourself. So now that you're done, I hope that your histogram looks like mine. Yes, there is no data from 40 to 49, and you might see here, that's a good reason why I'm alternating colors with my yellow and my green, just so that you can see when 2 bars are the same height side by side, it's easier to see how they might, be different, okay? So there's my first histogram counting in increments of 10. This time around, I'm going to count in increments of 5. I found 2 small mistakes that I made in my top one, so I'm going to make sure I take care of both of those mistakes right now. I made a title, but I'd never labeled my axis. So my y-axis, and I can feel with the board behind me, it's going to be a little bit hard to label, but my y-axis is number of students. And I'm going to do that on both graphs. And my x-axis, I forgot to label that first time around, so I'm going to do that right now too. This is amount of time it takes to get to school. And we're measuring that in minutes. Again, pause if you need to catch up. But if you're not pausing, if you're able to keep caught up, this time the book is wanting us to count increments of 5. That's very similar to up here counting in the increments of 10. So remember how I said it looks deceiving, like we're counting by, it looks like a difference of 9, but it's really 10 different pieces of data. This time we want 5 pieces of data. My increments though are in 5 this time. So again, it's kind of like thinking, like get my black marker back out. It's like I want this to be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, and 70. And as you can see, I purposely, made things line up. So my 10 and 10, my 20 and 20, just so we could see it a little bit more easily. But that same problem persists, like where would I put a 5 on this side or this side? So that's why when I teach my students this when we're at school, I'm showing them that this would be the 0 to 4. This would be the 5 to 9. This would be the 10 to 14, 15 to 19. And just like before, it's deceiving. It looks like I'm subtracting and it's only a subtraction of 4. But 5, 6, 7, 8, 9 is 5 pieces of data. So pause if you want to pause, but I'm just going to keep on counting here for a second. You just catch right back up with me. So I'm going to have a 20 to 24, a 25 to 29, a 30 to 34, 35 to 39, a 40 to 44, a 45 to 49, a 50 to 54, a 55 to 59, a 60 to 64, and a 65 to 69. It's nice to be able to see patterns. I see that the first number is always a 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and so on. The second number is always a 4 or a 9. So once you get into that habit of that pattern, it's pretty nice. My y-axis, I'm still going to count by 2s just so everything is consistent. Okay. And same thing, I'm going to just relook at my data table. And from 0 to 4, there's nobody from 0 to 4. So I'm going to leave that one blank. From 5 to 9, I have 6. From 10 to 14, I have 5. From 15 to 19, looking at my data table, I have 12. Okay, and here's the time where I encourage you to pause and try to do this on your own, and then just hit play when you are ready to move on. So I'm just going to keep on going. From 20 to 24 is 8. 25 to 29 is 2. 30 to 34 is 3. 35 to 39 is 2. 40 to 44 is nothing, and another nothing, and then 1, and a nothing, and a 1. Okay. All right, so I hope you successfully got caught up with me there. we're looking at our two separate histograms, and it's kind of interesting that they look similar, but yet there's some differences within them, and that's why I want us to take an opportunity to compare. So I have a couple of notes here that I'm just going to make sure I'm hitting on all the big topics I wanted to talk about. When I compare both of them, when I see the overall, it's nice to use the larger increments just to kind of say, all right, a lot of people are kind of in this less than 30 range. So overall, less than 30, the top one is better. But if I want a more detailed view, the smaller these increments get, the more detailed I can see. And it looks like I have a whole lot from 10 to 19, but when I come down here, I can see that the whole lot, it really isn't from 10 to 19. More of them are really in the 15 to 19 range. So the more bars you make, the more detailed you can see. That a lot here turns into really just a lot here, okay? Secondly, we briefly talked about these words in a different video, I believe, but we can once again see gaps and clusters. Gaps are exactly by namesake gaps. We see a gap in the data from 40 to 49, and that happens here also from 40 to 49. On the top graph, I only see one gap from 40 to 49, but as I said, it gets more detailed the lower we are. I see 4 gaps in the second set of data. The more bars, or the smaller the increments, the more detailed we get. We can also see the opposite of gaps, clusters. Clusters, again, are where we see a lot of similar data, where a lot of the data pieces fall. So when we have the tall bars that are really compact together, those would be considered clusters, and we see the exact same cluster in both graphs. But a downfall, a big downfall of histograms, it was a downfall of the box and whiskers, but the box and whiskers was even actually a little bit better than this. It's really hard to see exact data. So for example, let's pretend that this frequency chart did not exist. And if I was looking at exact data, what if I said how many students took 30 minutes to get to school? Well, if I go up here, I don't know. I know from 30 to 39 was 5 students, but I don't know how many were exactly 30. I'm gonna come down here and do the same thing. I can see from 30 to 34 was 3 students, but I don't know exactly how many were 30. And that's the downfall of histograms, getting the exact data. Now, if I look at the frequency chart, I can see that there were 3 students that had exactly 30, but I can't tell that from the graph. I'll pick another number. What if I say how many students took 3 minutes to get to school? Well, up here, 3 minutes is somewhere around 0 to 9, and it's 6 or less. But if I come down here, no students took 3 minutes to get to school, and I can verify that on my frequency chart. But I really can't pick out exact numbers very well, okay? This is something I also wanted to show you. So if you were to take all of this data and find the mean, the median, the mode, and the range, you should be used to those numbers by now. The mode is 15. So the mode is somewhere in here and somewhere in here. The median, if you were to calculate it, is 16. So that's somewhere in here. The median falls in that yellow bar. The median is also going to fall in that bar. The mean is 18.975. Mean falls in that yellow bar. Mean falls in this green bar. That's so important. Now, they're not always going to all fall in the exact same bars, but this mean, median, and mode is telling us what is typical of our data. And our data is typically between 10 and 19 minutes of a travel time to school. Even more specific, when I go down to that more detailed one at the bottom, the mode, the median, and the mean are all somewhere between 15 to 19 minutes. Even more specific than the 10 to 19. So if we were to get a brand new student at school and we had to make a guess as to how many minutes that student needed to travel to get to school, the best thing we can do is assume that it's probably somewhere between 15 and 19. Now, that doesn't mean that longer times or shorter times don't exist, but if I had to make a prediction, because my mode, my median, and my mean are all within this slot, That's pretty typical, or that's pretty expected. Okay, the range is 55, highest minus lowest. Because of what we talked about before, I don't know my exact highest number, I don't know my exact lowest number. Looking at this data, I can't get the 55, and I can't get the 55 by looking at this either. So a downfall of a histogram, that's why we have the frequency table to back us up, okay? So hopefully I think that's kind of everything in a nutshell. The biggest thing to focus on is knowing that you cannot see the exact data, but you can see trends, you can see clusters, you can see gaps. The most important thing as you're making your own histograms without our assistance is to make sure that you're knowing how to count, like 0 to 9 or 0 to 4s, okay? So if you have any questions, 6th graders, don't hesitate to ask. Your math teacher will happily help you out with this, but hopefully that's everything kind of in a nutshell for histograms. Have a great day.